Hello everyone, I hope you guys are doing well. Welcome to the second lecture video of the Data Science at Georgia Tech Bootcamp course. So in this video, we're going to be exploring exploratory data analysis. By the end of this video, you'll be able to manipulate data using pandas, which means you'll be able to filter data, understand how to view data, and understand basic statistical analysis and data visualization. So let's just jump into it. So for this video, we're going to be using the Titanic dataset. The dataset is pretty nice and great introduction to pandas. I've already put the dataset in a place in my Google Drive. Alright, so what is Pandas? Pandas is a data manipulation library, so let's import it and go through some of the basic commands. So Pandas' core element is a data frame, which is essentially a spreadsheet of data. Using data frames, we can explore data effectively and very efficiently with pre-built functions. In this cell, we create a data frame by reading in the CSV file we got from Kaggle that we put in our Google Drive. Kaggle, for those of you who are unfamiliar with, is a website that holds an enormous database of datasets to work with. We're using a built-in function called read_CSV from the Pandas library to create this data frame, and then storing it into this variable called df. Let's print the variable df out. So you can essentially see that it is a spreadsheet. In this data frame, there are 891 rows and 12 columns, so each passenger has features such as the fare paid, cabin, priority class, and others. So we have some different types of columns and features, and then our target, which is something we want to predict. In this case, we want to use the features available to us like sex, age, cabin, ticket, etc. to predict whether a passenger survived or not, which is what we care about. Turns out, we need to pre-process our data into a nicer, more predictable data frame. Unfortunately, we rarely receive a dataset that is already fully useful and provides us the information we need. There might be some missing values or some formatting flaws that we need to fix before we can effectively use the features to predict on the target. The pre-processing stage is where data scientists spend a lot of their time, and it is absolutely vital to being able to create good models. A nice thing is that in the pre-processing stage, we gain valuable insight into some of the intricacies of our dataset and useful knowledge about the nature of the data, which will be helpful when creating a model. So let's get into the first stage of pre-processing, which we call filtering. One basic operation is to extract some subset of columns. So here we are isolating some features and then also extracting a subset of the rows as well. So we will see some small subset of the features and the corresponding rows for those features. And if I print this out, you can see we have the first 7 rows and just a few of the features. This is much easier to read and analyze. Now, we may also want to focus on certain features if we think they might be more useful in exploring to gain some insight into our data. For instance, what if we think that being a male is a good predictor of survival rate? Then we can simply select all the male passengers and then gain some insight into their stats in comparison to the dataset as a whole. So as you can see right here, you can see the sexes of all the data points are all males, just like we'd expect. And you can see you could do something similar for, say, passengers that did not survive, or we could even select the number of males who survived and then gain some insight into the survival rate of males. Maybe you can think of how to do that, for instance. Another thing we can do is look for missing values, which is a common step in pre-processing data. We can check for missing values in our dataset by using the .isNull method, and then summing up the number of missing values for each feature. So let's run this method. Alright, we can see that age and cabin have a lot of missing values, so we can easily get rid of those features because they're essentially wasted space. So let's drop those two and a few others that we don't think will have an effect on survival rate, like passenger ID and ticket, for instance. And as you can see in our data frame, we no longer have those features at the top of the columns. Another problem you may encounter is empty values in your data. For instance, there are 2 empty entries in the embarked feature. We can deal with this in a couple of ways. We could possibly replace the empty values with the average of the columns. This works well for a numerical feature, but what if the feature is categorical, like the embarked feature? Then we might just want to remove the data points with those missing values. There are a lot of other ways to handle categorical data, but we're simply going to drop those null values for the purposes of this video, using the .dropNA method. And as you can see, we just dropped 2 data points, which is those that had null values for the embarked feature. There's no one-size-fits-all approach to data preprocessing. The only way to get better at data preprocessing is to work with many and many data sets. Some examples of some more advanced techniques you could do include standardizing your data, or maybe encoding categorical data into numerical values, since models like numbers instead of letters. So now that we are finished preprocessing our data, we're going to go into the next section, which is understanding statistical analysis. Statistics is an important toolkit when it comes to data science, because statistics allows you to help make sense of your data and assign meaning to it. Statistics gives you a way to quantify your findings, and one place to start with is to understand data distributions. Sometimes we need to see how our data is distributed. It is not easy to see this with our presentation of our data frame from earlier. We're going to focus on one type of distribution called the normal distribution. The normal distribution is the bell curve distribution, and it mimics a lot of natural phenomena. Things like blood pressure, IQ, height, weight, etc. can be effectively represented by a normal distribution. So in this case, the normal distribution centers around the mean. The further from the mean we go, the smaller the probability density becomes. Namely, the further from the mean we get, a smaller and smaller percentage of the data points will appear. For instance, something 2 standard deviations from the mean will encompass only 4.65% of the data points. So, why is this important to a data scientist? One theorem that comes in handy when dealing with statistical analysis is the central limit theorem. If you have ever taken a probability or statistics course, you have seen a lot of the central limit theorem, because it's a foundational topic in statistics. What the central limit theorem says is that a dataset will begin to look more and more like a normal distribution as more and more data is randomly collected. Let us look at the example of rolling a dice. When we roll a dice once, we don't see the normal distribution. It's just a flat curve, since we only have one data point. But as we roll more and more times, the distribution begins to follow a normal distribution. This is because the average of the values begins to come closer and closer to the theoretical average value. So that might or might not make sense for people seeing it for the first time. And it still might not be really clear as to why this is useful for someone wanting to learn data science. So we're going to demonstrate this using the Titanic dataset. So first, let's read in our Titanic dataset. As you can see, we have 891 rows and 12 columns, just like the original dataset. I want to specifically analyze the age column, but first let's drop the null values using the .dropNA method. And you can see we dropped about 170-ish values. So now we are going to split the dataset into train and test sets, which we will go more over later in the course. But for now, let's just say that we're using it to split the data into chunks of different sizes to demonstrate the central limit theorem in practice. Notice the chunk sizes of the variables x1 test, x2 test, x2 train, and x1 train, and x. x1 test is the smallest with 10% of the data, and x is the largest with 100% of the data. These methods below just print out the number of values in those variables. So now we're going to plot each of these splits. Let's start by plotting the first test split, which only has 72 data points. Using matplotlib, we can see that it doesn't really look like a normal distribution yet. So now let's plot the second test split, which consists of 30% of our data. This looks a little bit more like a normal distribution, but let's see what the last two splits look like. As you can see, as we add more and more data, and eventually up to 100% of the data, we're getting closer and closer to a normal distribution. So this is the central limit theorem at play using the Titanic dataset. Now let's get into some data visualization. The two code snippets below both create a histogram of the feature P class. We are essentially asking how many passengers are in first class, second class, and third class. So if I run these two code snippets, you can see that they both produce the same histogram and show that the majority of the passengers are in third class. Now, the histograms here look fairly messy, with the gaps in the x-axis and potentially misleading histogram values between 1 and 1.25, 2 and 2.25, and 2.75 and 3. We can clean this up a bit by first removing the gaps in the x-axis, so we can see this histogram here. And the next thing we're going to do is actually convert our numerical values into categorical values. We can do this using a dictionary and the .map method. And so after doing that, you can see that all of our data set is now a in terms of categorical values, first, second, and third. So if we plot that, we can see that we now just have a first, second, and third value. And we can use Seaborn to clean that up a bit. And so now we have a histogram that looks more appropriate and sharper. And you can look up more about the documentation of Seaborn and how these methods, such as .set, .histplot, work. Now, I want to look at the distribution of age. We can use the histogram to plot that. You can see it looks like a fairly normal distribution. And if I use Seaborn to clean it up a bit and plot a curve through the points, you can see that it looks pretty close to a normal distribution. One question we might have from these visualizations is that maybe it seems like people of a higher priority class might have an equal rate of survival as people in lower priority classes. But let's see the distribution of people who live and die based on their priority class. So let's read in the original data set. And I'm just going to use a few methods to plot the priority class versus the survival rate. What we're doing here is for each priority class, we're going to get the distribution of people who survive. So that's what this plot here does right now. One thing interesting you might see here is that in first class, more people are surviving than dying. But for third class, much more people did not survive. In the second class, the survival rate is a little under 50%. Looks like our initial theory that priority class does not affect survival likelihood was wrong, since first-class passengers were much more likely to survive than third-class passengers. But the exercise of going through the data and validating or disproving our assumption is a good exercise. So hopefully this gives you a good view into data visualization and pandas. Thank you everyone for watching, and we look forward to seeing you in the next video.